Alright guys, so last video we did 1 through 6. Now we're going to start with number 7 here, talking about completing the square to solve the following. So what we're going to do is we're going to start by moving this 30 over. Alright, so we're going to say, alright, go ahead, get out of here. We want to move our C term over so that we have 30 equals 3x squared plus 15x. Then we need to go ahead and take a GCF out from this side. So we'll go ahead and take out a 3. So we have 3x squared plus 5. Remember, it's not really a true GCF that we're taking out because obviously we still have that x in there. Really what we're doing is we are taking out whatever the leading coefficient GCF would be. Kind of gets it set up so we can convert into vertex form and then go ahead and solve. In here, I'm going to take this b and take it off to the side and do b divided by 2. And then I'm going to square that number, which is going to give me 25 fourths. That's what I'm going to be adding to both sides. However, when I add 25 fourths to this side over here, I have to remember to multiply it by 3, because in here, I'm adding 25 fourths on the inside of my parentheses. Okay, notice how the 25 fourths is going to go on the inside of my parentheses. So that means that over here, I need to make sure I add 3 times that, which would be 75 fourths. Okay, now 30 is actually 120 fourths. So 120 fourths plus 75 fourths is going to be 195 fourths. It's a lot of quarters there. We then know we can go ahead and factor on the one side. So we're going to have this over here. And our factor is pretty nice because whenever we factor this, we know that whatever we got inside the parentheses over here is going to be our factor because we set up a perfect square trinomial, x plus 5 over 2 squared. Now, we don't just stop here and say we're good to go, we'll just solve whatever. Now we have to go ahead and actually solve this. So we'll go ahead and divide both sides by 3, which really over here is the same thing as multiplying by a third. Okay, you're going to multiply by a third. So you're going to get 195 over 12 equals x plus 5 over 2 squared. And then we'll go ahead and we'll square root both sides. Okay. And then in the denominator, let's make some more room for myself here real quick. So get out of here, next problem. In the denominator, we're going to, I'll get my pen back. In the denominator, we're going to go ahead and take out a, let's write this out over here. Take out a perfect square. We can take out 4. So we're going to have 2 and then root 2 in the denominator. And then in the numerator, I'm going to notice that there really isn't anything that 195 that'll come out that helps me at all. So I'm just going to leave this as 195. And then make sure I have my plus or minus out front here. And then I'll go ahead and move this over by subtracting it. So I get negative 5 plus or minus the square root of 195, as I like butcher writing a 9, there we go, over 2 root 2. Now, this answer is actually not really acceptable because we have a radical in the denominator. And hopefully you guys know that radicals and denominators are a no-no. So, in order for us to fix this problem, we're going to have to rationalize our denominator, everybody's favorite thing to do. Basically, I'm going to multiply the bottom and the top by root 2 in order to get rid of this radical. So, if I do that in the denominator, I am going to get 4. And in the numerator, I'm going to get the square root of 195 times 2, which is 390. Okay, and then that's going to be my final answer, equals x. Okay, so just a quick recap, completing the square, move over your C term, then you're going to go ahead and factor out whatever your leading coefficient is. You're then going to go ahead and take this, divide it by 2, and square it. So you get 25/4. You go ahead and you add that to both sides. So 30 is 120/4. So sorry, a little mix up in the video. I had to pause for a second to don't get freaked out here. 120/4 and then 25/4. I have to multiply by that number that was in here because really I'm not adding 25/4. I'm adding 75/4. So 120/4 plus 75/4 equals 195/4. I then go ahead and divide both sides by 3. Dividing by 3 is the same thing as multiplying by a third. That's after I factored this, okay? So multiplying by a third is 195/12. I then went ahead and square rooted both sides, get this by itself. Remember my plus or minus out front. And I rationalized to get my final answer of -5 plus or minus the square root of 390/4. Down here for 8, 9, and 10, I want to know how many x-intercepts the following quadratics are going to have. I do not need to do a whole lot of work here. I don't have to factor or do quadratic formula, do all that jazz. All I need to remember is that my discriminant, the b squared minus 4ac, will tell me how many roots I'm going to have. Okay, sorry, there's another glitch in the video, so I apologize. Probably freaking out by now. Like, what's going on? Anyway, if this equals 0, you're going to have one x-intercept, okay? So you're only going to have one real x-intercept. If it is greater than 0, that means that you will have two x-intercepts. And if it is less than 0, that means that you will have no x-intercepts. Okay, remember, this all has to do with, because it's underneath the square root, it kind of tells us whether we're going to get imaginary roots and therefore no x-intercepts, or if we're going to get real roots and therefore some number of them. Okay, so just have to do b squared minus 4ac. If you do that with the first one, you should get a positive number. Okay, 49 minus 4 is what you get, so you get 45. So that would mean that the very first one is going to have two x-intercepts. When I do the second one, I have 81, so it's b squared is going to be 81, minus 4 times 2 times -10. Once again, I'm going to notice that I'm going to be getting a positive number. That means I have two x-intercepts. The third one is going to be the first one that bucks the trend. When I could do this, I'm going to have 1 minus 4 times 34 times 1, which I'm going to realize is going to be negative. You'll notice I'm not even doing the whole calculation. I'm kind of just writing it out and looking at it. If you want to do the whole calculation, that's fine, but all you need to notice is whether it's positive or negative. The actual number doesn't matter that much. So because it's going to be negative, I know I will have 0 x-intercepts. All right, so that discriminant, the b squared minus 4ac, that is all that you care about when it comes to how many x-intercepts the following quadratics will have. Now, go to the next section here. Let me make myself some more room real quick. The next ones you had to graph on a piece of paper, state the roots, the vertex, the axis, symmetry, all that lovely stuff. When we go to graph, remember there's two different strategies that we have for graphing. We can either use the vertex and 2 points next to it, or we're going to need to use the roots and the vertex. No matter what, we're going to want to use the vertex. Now, the vertex in this case, -b/2a is the x-coordinate, and then you plug that back in to get the y-coordinate. So the y-coordinate is f of -b/2a. Luckily for us, the very first one's nice and easy because the vertex is going to be at 0, 0. So I'll go ahead and put my first point at 0, 0. Let's pick a different color. We'll pick blue here. Okay, so that's my first point. That's going to be at 0, 0. Now, this one, because this is a root, I'm going to have a hard time using my roots as my other 2 points because this is the only real root I'm going to have. So instead, I want to use the 2 points next to it. So I'll go out to 1, and I'll go out to -1, and I'll plug those into my quadratic here and see what I get out. If you plug those in, you'll see you get 8 out. So I'll go up to 8. I'll go ahead and plot 2 points there. And then I'll go ahead and draw my quadratic. Boom, boom. There's our quadratic. It's a lovely sketch. Your axis of symmetry goes through your vertex. Your axis of symmetry goes right through here. Okay. Now this one over here, we can choose to use roots, or we can choose to use the vertex and 2 points around it. That's supposed to be an arrow down here. That did not come out very well. For this one, it's actually going to be pretty easy to factor. You can see this actually is a difference of squares. So really this is 3x plus 6 and 3x minus 6. Okay, we also could have taken out a 9 and then factored this because this is x squared minus 4. So really we're going to get that x equals 2 and x equals negative 2 as our roots. So pretty easy roots. So we go ahead to 2 and we'll plot that. And we'll go ahead to negative 2 and we'll plot that. So we have our 2 roots. Now the next thing we're going to do is find the vertex. The vertex is negative b over 2a. You'll notice we're missing our b term here. So it's a 0 that goes in for that. So it's 0 over 2 times 9, which will be at 0. So we know our vertex is going to be occurring at 0. If I plug 0 back in, I will get negative 36. Now, you'll want to be creative with your scale, obviously, if you're using graph paper. I would not go by 1 to go all the way down to negative 36. Maybe go by 4s on the y-axis. As long as you label it, it's okay. But you're going to go down to negative 36. And that's where you're going to put your other point. And then you can go ahead and draw your quadratic. And again, please pardon my beautiful art with the mouse. Last but not least, we have this one over here. Again, I can use either the vertex and the 2 points next to it, or I can use the roots and the vertex. This quadratic is not factorable over here, which means that it's probably one that I would like to use the vertex and the 2 roots. So we're going to go ahead and do negative b over 2a. If I do that, I'm going to get 16 over negative 10, which is really, I can take out a 2 from each of these, so it's really negative 8 over 5, negative 8 fifths. So I'm going to go to negative 8 fifths. In all reality, that is between negative 1 and negative 2. So if you're plotting this on a piece of graph paper, you want to make sure you're going somewhere in between negative 1 and negative 2. And then I'm going to go ahead and, plug that back in and see what I get out from this when I plug negative 8 fifths in to get what my y value is going to be. If you go ahead and plug all that in, you're going to get 89 tenths, which is, or 89 fifths, which is a pretty high number. So again, you want to be a little creative with your scale. I'll go ahead and put in 89 fifths. And I'll put my point there. Now, I'm going to go ahead and I want to pick 2 more points to get a general idea of what the shape of this quadratic is going to be. You do not necessarily have to pick points right next to your vertex. Just make sure you pick one on either side. In fact, for the sake of easiness, I'm probably going to pick the point 0, because when I plug 0 in, I'm going to get, so 0, if I plug this in, I'm going to get 5. Okay, so I know at 0, I'm going to get 5. And then I know symmetry of my quadratic that the same distance from the vertex on the other side is also going to give me 5. So 0 was me going from negative 8 fifths here, so it's 8 fifths up. So I want to go 8 fifths away to get to the other point that's the same distance away. So we went 8 fifths this way to get here. So really I want to go another 8 fifths this way, which would be negative 16 fifths would be the equidistant one away, which is like a little bit more than negative 3. And then that's also where I'm going to have it be 5. And then I'll go ahead and draw my quadratic, which is just lovely again. Okay, and end up with my quadratic. That was 10, 11, and 12. And I'll see you guys back for another video for 10, 11, 12, and 13. I'll see you guys back for another video for the rest of your practice test.